So in this video we're going to go over the component form of a vector. So here's the idea for the component form. If we have a vector v and we know its initial point is at x1, y1 and its terminal or ending point is at x2, y2, then we get the component form of that vector by taking x2 minus x1 in the x position of the vector and y2 minus y1 in the y position of the vector. And what we want to recognize is that this difference here is just a directed distance in the horizontal direction, and this is just a directed distance in the vertical direction. And what I mean by that is, let's take a look at these two generic vectors here. I have one with initial point x1, y1, terminal point x2, y2. And if I break this into a horizontal and vertical component, creating a right triangle, this distance here is going to be the distance in the horizontal direction given by x2 minus x1. And because this vector is in the horizontal direction pointing towards positive infinity, x2 minus x1 is going to be a positive number. So it's actually the positive distance from here to here, or as you move along the vector in the horizontal direction, whereas this distance here is going to be the distance y2, the second y coordinate, which is a height, minus y1, which is also a height. And because the vector is moving towards positive infinity in the vertical direction, y2 minus 1 is going to be positive. So we get a directed distance. The distance from here to here is x2 minus x1, positive because the vector is moving towards positive infinity. As we move from here to here, the distance is y2 minus y1, and positive because we're moving towards positive infinity. So we get directed distances in here. This vector here, which it starts with the initial point here and terminal point here, if I create a similar right triangle, then this distance here is going to be x2 minus x1. It's still a horizontal distance, but this number is going to be negative because we're moving towards negative infinity in the horizontal direction. So the base of this right triangle would actually have length x2, the absolute value of x2 minus x1. But in the vector, we don't kill the negative sign. We just leave the directed distance in it. It's a negative component. And then here, the vector's moving, as it moves from its initial point to its terminal point, it's moving towards negative infinity in the vertical direction. So we get a directed distance right here, y2 minus y1. It's going to be negative. The actual height of this right triangle, I would need to take the absolute value, but we don't kill the negative sign when we create the vector. We leave it as a directed distance. So if we do a concrete example, if we have a vector u with initial point 3, 2 and terminal point 8, 3, to find the vector u in component form, it would be x2 minus x1, comma, y2 minus y1, which is just going to be the vector 5, comma 1. And both components are positive because as this vector moves in the horizontal direction, it moves towards positive infinity, and as it moves in the vertical direction, it's moving towards positive infinity. We get the two positive components. Here, this vector has exactly the same 2 points, but now 8, 3 is the initial point and 3, 2 is the terminal point. So when we calculate the vector w, we're going to get, here's our x2 minus our x1, comma, and then it's going to be y2 minus y1, which is 3, and we wind up with the vector negative 5, comma, negative 1, which if we factor the negative out, we actually see this vector, because it's the same length but pointing in the opposite direction, is actually the negative of vector u. So again, these are the vectors in component form, and the vector components are directed distances.